Hi everyone, I'm Sangwoo. In this video, I would like to share some thoughts about correlation on top of existing useful books and video clips to help you understand it more clearly. I will assume you have basic knowledge about correlation while I'm explaining it in this video. If you Google correlation, correlation is defined as a mutual relationship or connection between two or more things. In statistics, correlation means Pearson correlation typically. The Pearson correlation is also known as Pearson's R, the Pearson product moment correlation coefficient, or simply correlation. According to Wikipedia, the Pearson correlation coefficient is a statistic that measures linear correlation between two variables, x and y. This is correlation coefficient formula from random samples. Are you familiar with this? We also can statistically test it because it is a statistic. The test statistic is rho equals 0. It has t-distribution with n-2 degrees of freedom. Is that enough to clearly understand correlation? I want to share 5 things to help you clearly and fully understand correlation in this video. Number 1, linear relationship. For case A, we say that there is a strong positive correlation, and for case B, we say that there is a strong negative correlation. And for case C, there is a strong non-linear relationship. The Pearson correlation does not measure this kind of non-linear relationship. And for case D, there is no correlation. The linear relationship is not equal to slope. The left graph and the right graph has different slope, but they have same correlation coefficients. Number 2, test statistic. As I mentioned in the previous slide, correlation coefficient has test statistic. There are 12 samples, and once we measure correlation coefficients, it has 0.477. But in p-value, we cannot say that there is a strong positive correlation considering 5% significance level. But once I double sample size, the Pearson correlation is the same as this one, but the p-value is less than 5%. So in this case, we can say that there is a significant correlation between two variables. Number 3, it measures how much variation they share. According to correlation coefficient formula, the numerator part is covariance. So the more they share a variation by covariance, the larger correlation coefficient is. Number 4, numerator decides coefficient direction, plus or minus. As you can see, the denominator part is always positive. So let's look at numerator part. Once we have data samples like this, the first quadrant and the third quadrant is showing positive sign. So xi minus x bar is greater than 0 and yi minus y bar is greater than 0. So if we multiply by those two, then the sign is positive. The third quadrant, so xi minus x bar is less than 0 and yi minus y bar is less than 0. So if we multiply by those two, then the sign is positive. So that's why we can have positive sign correlation once we have this kind of data. Number 5, relationship between two vectors. In middle school or high school, we have learned about cosine theta. So once we define A vector and B vector, cosine theta can be measured by this formula. So the numerator part is inner product of two vectors, and denominator part is magnitude of vector A and magnitude of vector V, and we can multiply by it. Then we can get cosine theta. We also can write cosine theta as this kind of form. Let's think about data matrix, n by p data matrix. Select two columns and we can define the first column as x vector and y vector. Then we can imagine this kind of data matrix. And according to correlation definition, we can write down correlation xy as this kind of form. And replace xi minus x bar as ai and yi minus y bar as bi. Then we can say correlation between x and y can be written as this kind of form. So it's exactly same as cosine theta. So correlation means cosine theta between two vectors. Let's check it from Excel. Okay, let's practice basic Excel functions first to convert degrees to cosine and cosine to degrees. So for example, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees. So we can use the radian function, radians. Right. Or we can directly calculate radians from degrees by using this formula. Let's say multiply by pi function and over 180. Yeah, so we can have same result here and here. And to get cosine theta, we can use COS function, COS and radians. Okay, so you know cosine 0 degrees is equal to 1 and cosine 60 degrees is equal to 0.5. And also we can get degrees from cosine theta value. So let's say this one, and copy and paste. So let's get radians first from cosine theta. In this case, we can use arc cosine, ACOS function. Okay, and we can get degrees from cosine theta directly by using this formula. Let's say A cosine, arc cosine I mean, and multiply by 180 and over pi function. Alright, so I showed you how to calculate cosine theta from degrees, and also from cosine theta I showed you how to calculate degrees. So based on this knowledge and information, so let's get correlation. So in the previous slide, I showed you this data, and in Excel we can use correlation function, CORREL, and select first array, and comma select second array. Cool. So in order to get correlation by using vector formula, so we need to center the raw data. So x minus average, press F4. Y minus average of all y values press F4. Right, because I mentioned that these two vectors starting from origin, right? So let's calculate correlation by using this cosine theta formula. So the numerator parts we can consider using some products, some PRO, first array, comma, and second array, and over QRT, A1 squared plus A2 squared, etc. We can use some SQ function, some SQ. This one, and multiply by SQRT, some SQ. This one, right? And we need to, we use parentheses here, right? And press enter. Right. So we got same results. So let's calculate the degrees from this correlation value. So ACOS, correlation value, coefficient, I mean, multiply by 180 and over pi function. Cool. So correlation coefficient 0.47 is around here, and this degree is around here. Yeah. So that's it. Please click like and subscribe if you have enjoyed this watching this video, and I'm also looking forward to seeing you from another video. Thank you.